This is mathheals.com, where you can find more links to other math YouTube videos if you wish. And let's look at the dot product. Now the dot product goes like this. If you have your first vector, and maybe I shouldn't use u, I'll use v. Is equal to a sub 1 I plus b sub 1 j, and w is equal to a sub 2 I plus b sub 2 j. Then our dot product is a1 times a2 plus b1 times b2. Now v, w, I, and j are all vectors, and the a1, b1, a2, and b2 are scalars, numbers. So the dot product is pretty straightforward formula. Now sometimes it'll ask you if two vectors are parallel, and they're parallel if there exists a number such that v is equal to nw. What does that mean? Well, if I have like v is equal to 3i plus 2j. Now if I multiply these by 4 times 3i is 12i, and 4 times that is 8j. So you see how this is 4 times 3i plus 2j. So that's how you tell so they're parallel. And then orthogonal if the angle between them is 90 degrees. Now 90 degrees, remember the word we used before, perpendicular. Well, orthogonal refers to vectors. Same idea. Now to find the angle between them, use this formula. You got cosine theta is equal to the dot product, that's not u times v, that's a dot product of u and v, over the magnitude of u times the magnitude of v. And I thought I actually saved that in class. Put a little multiplication between it there. Where's multiplication? There. Don't confuse that. The top is a dot product, the bottom is actually multiplication. Okay, let's look at our first example. We've got v is equal to the square root of 3i plus 3j, and w is equal to I plus j. It says find dot product. It's part A. Well, a dot product is very easy. You take the number before your i's and multiply them together. So square root of 3 times the 1. And you multiply your numbers in front of your j's together. So we've got 3 times 1. So that gives us square root of 3 plus 3. And that's our dot product. B, find the angle between them. Well, we said cosine, what was it, theta or alpha? Theta. Cosine theta is equal to the dot product of v and w over the magnitude of v times the magnitude of w. Well, the magnitude of v and w is this, or I mean dot product, sorry. The dot product of v and w is the square root of 3 plus 3. The magnitude of v, well, v is this, so I'm going to take the square root of 3 and square it, and then I'll add 3 squared. Now the magnitude of w, we're going to take 1 squared plus 1 squared. So you take the number before the I, square it, number before the j, and square it, and put a square root over it. For the w, the number before the I and j is invisible 1, so we got 1 squared plus 1 squared. Which gives us square root of 3 plus 3 over. You square the square root, it just gives you 3, plus 3 squared is 9. And 1 times 1, or 1 times 1 is 1, 1 times 1 is 1, so 1 plus 1 is going to give us 2 eventually. So we got cosine theta is equal to square root of 3 plus 3 over 12 times 2. It's probably easiest to do a little bit of simplifying before we go on with this. We got square root of 3 plus 3 over square root of 12 times square root of 2 is square root of 24. Now we're going to take inverse cosine of both sides. So we got theta is equal to inverse cosine of square root of 3 plus 3 over the square root of 24. Now, if you have more than a single number, single radical, single variable, and top or bottom fraction, put parentheses around it. So when we plug this in, we had to put parentheses around the square root of 3 plus 3. Well, let's see what this gives us. So do second. You want to make sure you're in degrees, so press mode and make sure it says degrees. If it doesn't, down arrow to it, right arrow, put your flashing cursor on a degree and press enter. Okay, so now we'll do inverse cosine of beginning parentheses, second x squared for the square root, put a 3, put a closing parentheses on the square root, plus 3, closing parentheses on the top part, divided by, and we got a single square root downstairs, so we don't have to put parentheses around it. So do second x squared, 24, and you can put closing parentheses on if you want at the very end, but you don't need them. And then press enter. And we get theta is equal to 15 degrees. Now, if I were to graph these, and it doesn't have to be kind of too precise, but square root of 3, that's I think 1.7, and this is 3, so 1.7 and 3 would be like right there, that vector. And this is 1 and 1, which is right here, which looks like that, which looks like about 15 degrees, so that seems normal. Now C says state whether the vectors are parallel, orthogonal, or neither. Okay, parallel. Let's start with one of these. I'll start with the W here. We got I plus J. If I take this J, I'd have to multiply it by 3 to get this 3J here. Well, if I multiply the I by 3, will I have this? No. So it's not parallel. Orthogonal means your angle is 90 degrees. It's not that, so it's neither. So again, what you do is you look at just one of them, and you ask, what did I multiply by J to get this new J? So I multiplied by 3. So then if you multiply the other one by 3, it should equal to this if they're parallel. Let me scroll down. Let's look at our next problem. We got V is equal to 5I plus J, and W is equal to negative 2I plus 4J. And we want to find our dot product. So we take numbers before the i's and multiply them together. So 5 times negative 2. And take numbers before your j and multiply them together. So 1 times 4. Then we're going to add those. 5 times negative 2 is negative 10 plus 4, which gives us negative 6. Now our angle between these. We're going to take our dot product, V and W, over the square root. Actually, let me write the formula down first. I was going to dive right in. Magnitude of V times the magnitude of w. Well, the dot product of v, and w we found in part A. That's negative 6. And this will be the square root of 5 squared plus 1 squared. We take a look at v, and I square the 5, and I square the number for j, which is 1. Now the magnitude of w. We take the negative 2, the number before I, and square it. So negative 2 squared, and then the 4 squared, the number in front of our j. So we get cosine theta is equal to negative 6 over 5 squared is 25 plus 1 is 26, so square root of 26. And this is 4, and that's 16, so I'd give us 20. Double check that. Okay, that looks right. Now, if you can, simplify it. 26 times 20 gives us 520. When I say simplify it, I mean get a single radical if you can. It's easier to plug in your calculator. We'll take inverse cosine of both sides. Like that. And let's see what that gives us. So I'll do second cosine. And we've got negative 6 divided by second x squared for the square root, 520. And we got 105.3. I don't know how many decimal places to take it to, so I'll take it to 1. Like that. That's the angle between them. And again, if we graph them, it should be kind of obvious. 5 and 1, so we'll go to 5 on our x-axis, and 1 would be right here. So that's our first vector. Second one is negative 2, 4, which would be right there. And if I look at that, that more or less looks like 105.3 degrees. So again, we're finding the angle between them. So finding out what that angle is. Now C. Determine if they're parallel first. Well, let's start with one of them. I'll start with the j here. What would I have to multiply by the j to get my 4j? Well, I'd have to multiply by 4. But if I multiply the 5i by 4, does that give me this? No, it doesn't. So they're not parallel. Orthogonal means the angle between them is 90 degrees, and it's not that. So this is another neither. I'm not exactly circling my answers here, but that's our first answer. This is our third answer. And up here, that's our third answer there. I probably don't have room. Well, I know probably I don't have room. So let me save this. I think this is called the dot product. Yeah. Trig. The dot product. Page 01.pdf. There we go. And let's look at our next problem. We've got V is equal to I plus J, and W is equal to I minus J. First thing we'll do is find our dot product. Take numbers before our i's and multiply them together. So I got 1 times 1, plus, then you multiply numbers in front of your j's. So I got 1 times negative 1. So we got 1 minus 1, which gives us 0. Now, to find our angle between them, we use cosine theta is equal to the dot product of V and W over the magnitude of V times the magnitude of W. Well, up on top we got 0, and on the bottom there's really not much need to find that. I know it's not 0. 0 over anything is 0. Actually, let me show it just so you have another example, though. Okay, so square root of V, so the number before 1, or before I is 1. Number before j is 1, so we've got 1 squared plus 1 squared. Now in this one, number before I is 1, so we've got 1 squared plus number before j is a negative 1, so we've got negative 1 squared. So we got 1 squared of 1, 1 times 1 is 1, so 1 plus 1 gives us 2. So square root of 2. And this is also square root of 2. Because 1 squared is 1, negative 1 squared is 1. Now if I multiply those together, we've got cosine theta is equal to 0 over square root of 4, which gives us 2. And then you just get cosine theta is equal to 0. Okay, now we're going to take inverse cosine of both sides. And this is actually on a unit circle, so I could use that, but let me go ahead and do the calculator. So do second cosine, put 0 on, and we get 90 degrees. Okay, that's the angle between them. This is our dot product. C, if they're parallel. Well, they're not, obviously not parallel. Here's I and here's I, and this is j and this is negative j. So, but our degree or our angle between them is 90 degrees, which means they're orthogonal. Try writing that a little bit more legible. There, orthogonal. If I were to graph it, 1, 1 would be this vector. 1, negative 1 would be this vector. And I see that the angle between them is 90 degrees. And that they're orthogonal. Let's look at the next one. Okay, so we got V is equal to 2I plus 3J. And W is equal to 8I plus 12J. Our dot product, part A. Multiply our numbers in front of our i's. So we got 2 times 8, then plus, and we multiply numbers in front of our j's. So 3 times 12. So that gives us 16 plus 36, which gives us 52. Now B. Find the angle between them. So we're going to find dot product of V and W. Divide by magnitude of V times the magnitude of W. Well, dot product of V and W is 52. And then we got square root of, then I'll look at the V. The number in front of our I is 2, so I got 2 squared, plus the number in front of our J is 3, so we got 3 squared. For our magnitude of W, the number in front of our I is 8, so we got 8 squared. Number in front of our J is 12, so we got 12 squared. So we got 52 over 2 squared is 4, plus 3 squared is 9, so was that 13? 4 plus 9, yeah. And then this one is 64 plus 144. Yeah, 144. So then we got square root of 13 times something, 208. Yeah, 208. Now I'm going to go ahead and just plug that in the calculator as is. So we take inverse cosine of both sides. Now again, when you have more than a single number, single radical, single variable in top or bottom of your fraction, you put parentheses around it. So when I plug this in, I want to put parentheses around the bottom part. So let's see what we get. So I'll do inverse cosine, 52, divided by, parentheses around the denominator, So beginning parentheses, square root of 13, so second x squared, 13, closing parentheses on 13, times second x squared, 208, closing parentheses on 208, closing parentheses on denominator, closing parentheses on inverse cosine, and enter. Then we get 0. So the angle between them is 0 degrees. Kind of tells you something right there. If it's 0 or it's 180, that should send off warning bells. Now let's look at the 2i. If I multiply that by 4, that would give me the 8i. And if I multiply the 3j by 4, that'll give me the 12j. So it looks like if I multiply both of these by 4, that'll give me the other vector, which means they're parallel. So if you can find a number you can multiply it by, such it'll give you the other vector, and you have to multiply it times both pieces, the I and the j piece. So those are parallel. Let's save that. And let's look at our last problem. As the formula goes along with it, and we'll flip back to this formula. But this says a decomposition of V into V sub 1 and V sub 2, where V1 is parallel to W and V2 is orthogonal to W, is given by these formulas. So we'll come back to that. Okay, so we got V is equal to negative 2i plus 5j, and W is equal to 4i plus j. It says decompose V into two vectors, V1 and V2, where V1 is parallel to W and V2 is orthogonal. So these are basically just formulas. So V sub 1 is equal to dot product of V and W over the magnitude of W squared times W. Okay. Well, the dot product of V and W, multiply the numbers in front of your i's together. So we've got negative 2 times 4 plus, then you multiply numbers in front of your j's. So I got 5 times 1. Now here, this is the magnitude. So this will be the square root of W, which is 4 squared, plus 1 squared. And all that squared. Now again, the magnitude of W, you take your number before your I, which is 4, you square it. Take the number before your J, which is 1, and you square it. And then you have square root over it. And then times our 4i plus j, our vector W. Now the dot product always gives you a number. The magnitude gives you a number. So here we just got a number times a vector. Well, negative 2 times 4 is negative 8 plus 5. Now the square root and the second power cancel each other out, and you got 16 plus 1 gives us 17. 4i plus j, which gives us negative 3/17 times 4i plus j. And I'll multiply that through, and that gives us negative 12/17 I minus 3/17 j. And that's V sub 1, the first thing we're finding. Now that's not the exciting one. It's the one with the most calculation, but this is the one that's more exciting. I could come up with any vector that's parallel. So this is parallel to W here. But if we multiplied it by negative 3/17, well, I can multiply by 1/2. I can multiply by 7. There's actually an infinite number of answers I can multiply by. But the key is that then we can use this in this calculation to help us get a vector that's orthogonal, or you can think perpendicular to this. And that's kind of the neat part. Now we'll take V, which is negative 2i plus 5j minus V1, which we just said was negative 12/17 I minus 3/17 j. So we got negative 2I plus 5j. Negative negative becomes positive, so we got 12/17 I. And here this negative flips that sign too, so it becomes a positive 3/17 j. Well, let's put the i's together. So we got negative 2 plus 12/17 I. And let's put the j's together. So we got 5 plus 3/17 j. This is a mixed number. Negative 2 times 17 is negative 34. Plus 12 gives us negative 22, I believe. 17 I. 5 times 17 is 85? Yeah, 85 plus 3 is 88. So that gives us 88/17 j. Assuming I did my basic math right, which is always kind of questionable. That looks right. Okay, so those will be our answers. So that is orthogonal to W. So kind of a neat way to get two vectors that are orthogonal to each other. Let me save that. When you're looking at these again, sometimes you say, well, there's not a whole lot of purpose for this, but you get into like physics, and you see that you can use these in other applications to help you figure out various items. I think that was our last problem. Yes, it was. Hopefully I saved that. So let's stop the recorder. And the dot product.